Bismillahirrahmanirrahim. Okay, so now we're gonna be solving a few questions from DC circuits. Distinguish between EMF and potential difference. So EMF was when our chemical energy was converted into electrical energy. Okay, like you need to write per unit charge. Per unit charge. This is important to mention. Per unit charge. So the definition would be chemical energy converted into electrical energy per unit charge. The amount of chemical energy converted into electrical energy per unit charge is your EMF, and your potential difference was amount of electrical energy converted into other forms of energies per unit charge. And now we have a circuit with an EMF of 12 volts and an internal resistance of 0.5 ohms. It is connected to two identical lamps as shown in figure 6.1, and these lamps are in parallel. Each lamp has a constant resistance. The power rating of each lamp is 48 watts when connected across a potential difference of 12 volts. Explain why the power dissipated in each lamp is not 48 watts when connected as shown in figure 6.1. Because our terminal potential, it's not gonna be 12 volts, it's gonna be less than 12 volts, because of the presence of an internal resistance. So you just need to mention that due to the presence of an internal resistance in the battery, the lamps will not receive the full 12 volt EMF. Calculate the resistance of one lamp. Okay, so we know that for the lamp, when it receives a potential difference of 12 volts, its power is 48 watts. And if we look at our formulas, we have power is equal to VI, I square R, and V squared. Now this is the formula we're going to be using. We have V, we have P, we need to calculate R. So P is equal to V squared divided by R. So P is equal to V squared divided by R. R would be V squared divided by P, and that's gonna be R is equal to 12 squared divided by 48, and that is going to give you a value of 44 divided by 3 ohms. Calculate the current in the battery. So now we know that this is 3 ohms and this is 3 ohms. And if you wanted to calculate the current in the battery, we need to know the total resistance the battery, the EMF is facing now. So V is equal to IR. This would be our EMF, and this would be the total resistance, and that means the internal resistance plus the circuit resistance. So our internal resistance is 0.50 ohms, and our lamps are connected in parallel. So if we calculate the resistance of the lamps, that's going to be 1 divided by R is equal to 1 divided by 3 plus 1 divided by 3. So 1 divided by R is equal to 2 divided by 3, and if we take a reciprocal of this, R is going to be equal to 3 divided by 2, which is 1.5 ohms. So the resistance of the lamps, that's gonna be 1.5 ohms. So we're gonna get 0.5 ohms plus 1.5 ohms, so a total resistance of 2 ohms. And if we use that in our formula, V is equal to IR, that's gonna be 12 is equal to I times R, which is 2 ohms. I will be 12 divided by 2, that's gonna be 6 amps. So our answer is going to be 6 amps. Calculate the power dissipated in 1 lamp. Okay, so for the power dissipation, we're gonna look at these formulas, and you can see that we have this formula I square R. I square R, we have the current, we have the total current, and we have we have the total current. Power is equal to I square R. We just calculated the resistance of each lamp in the previous part, which was 3 ohms. So R is equal to 3 ohms. Now what is our value for current going to be? Because the lamps are identical, right? Because these lamps are identical, the current divided, it's gonna be divided equally between these two. So 3 amps is going to go over here, and then 3 amps is going to go over here. If the resistance were different, right? If you have a parallel circuit where the resistance are different, in that case, your current, that's gonna be divided differently. It's gonna be divided depending on the resistance values, and the lower resistance is gonna get more current. So just for an example, if this was 2 ohms and this was 5 ohms, more current is gonna pass through the 2 ohm resistor than the 5 ohm resistor. We can just directly write 3 amps because we know that these are identical. But if we wanted to, the proper method would be you have 12 volts over here, and you have 0.5 over here, right? And you know that the total current is 6 amps. So first you would calculate कि जो हमारा internal resistor in the battery, how much voltage is this taking up. So that's gonna be 0.5 V is equal to IR. Our voltage is going to be 0.5, that's our resistance, multiplied by our current, which is 6. So that's gonna give us 3 volts. So 3 volts, this internal resistance is eating up 3 volts. So at the terminals, we're actually getting a total of 9 volts across these terminals outside the battery, because 3 volts are being used up by the internal resistance. So now we know that the lamps have for the lamps would have a voltage of 9 volts. That's the potential difference that's being supplied to the lamps. Now we can use the same formula. V is equal to IR is such like it's like the formula you need to know. It's like the formula, you know, because it's everywhere. You can apply this almost everywhere. V is equal to IR. So 9 volts is our potential difference across the lamp, and our lamp has a resistance of 3 ohms. If we use this to calculate the current, it's gonna be V divided by R is equal to I. V is equal to 9 and R is 3, so that gives us 3 amps. This is like the mathematical way of doing it. Like if you had different values for resistance, then you'd use this formula, but because these are identical lamps, the current is divided equally, so you can just directly write 3 amperes. You don't need to calculate them individually. So Our R is 3 ohms and our current is 3 amps. So if we calculate the power, that is going to be I square R, that's 3 amps squared multiplied by 3, so that is 9 multiplied by 3, that is 27 watts. A third identical lamp is placed in parallel with the battery in the circuit of figure 6.1. Describe and explain the effect on the terminal potential difference of the battery. So they're asking us what the effect on this 9 volts is going to be. What they've done is that they've added another lamp over here like this in parallel with the existing two lamps, and now they're asking us what the effect of what happens to this value. That's what they're asking us. For that we need to see what happens to the overall resistance of the circuit. Why? Because this the terminal voltage, this one, depends on the amount of current flowing through the battery. So if there's a greater amount of current flowing through the battery, then the internal resistance is not changing. V is equal to IR. This R is going to be constant, it's not gonna change. But if we have a greater current flowing through the battery, then we're gonna have this resistor is gonna take up more of the voltage of the EMF, तो ज़्यादा खाएगा. That's why we need to see कि अगर हमारी सर्किट की resistance decrease करती है तो current increase करेगा, and that's gonna result in a lower terminal voltage. अगर हमारा resistance increase करती है then current is gonna decrease, that means हमारे terminals पे ज़्यादा voltage आएगा. We've added another identical lamp जिसकी 3 ohms resistance है ना. So now now our new resistance is going to be 1 divided by R, 1 divided by 3 plus 1 divided by 3 plus 1 divided by 3. पहले हमारे पास वाली दो lamps है ना, now we have this additional lamp now. Now if we calculate the total resistance, that's gonna be 3 by 3, 1 divided by R. So if we take a reciprocal, that's just gonna be 1, क्योंकि 1 का reciprocal 1 होता है. So our new resistance is 1. Our previous resistance was 1.5 ohms. So हमारी resistance, it went from 1.5 ohms to 1 ohm. It decreased. And a decreasing resistance means a greater current. Why? Because V is equal to IR. EMF तो हमारा उतना ही है ना, EMF हमारा उतना ही है. तो to get 12, if our resistance is lower, we'll need a greater current because our product it's constant, it's 12. And because now our current is increasing, a greater value of current means कि जो potential difference ये internal resistor use कर रहा है ना, that's gonna increase as well, because they're directly proportional. The more current that's flowing through the internal resistor, the greater the internal resistance drop is going to be. So that's we need to write that over here. A third lamp, identical lamp, is placed in parallel with the battery of circuit and effect on the terminal potential difference. Adding an identical lamp decreases the circuit resistance, hence more current flows. And the internal resistance uses up more of the EMF voltage decreasing the terminal voltage. Okay, after that we have another question. A battery is connected in series with resistors X and Y as shown in figure 6.1. We have two resistors, we have X and we have Y, and we have this resistor over here. This is called a variable resistor. हमने potentiometers को भी देखा था ना, a symbol with an arrow in it, that's used for variable resistors. इसका मतलब है you can manually change the resistance of this resistor. It's controllable. The resistance of X is constant. The resistance of Y is 6 ohms. So this is 6 ohms. The battery has an electromotive force of 24 volts and zero internal resistance. That means कि जो हमारा terminal voltage है ना, this and this is our terminal voltage, and that is also going to be 24 volts क्योंकि हमारे पास कहीं पे भी ना वो नहीं हो रहा, कहीं पे भी हमारा ना वो voltage drop नहीं आ रहा inside the battery. And we have a graph, it's a current and resistance graph. So as your resistance increases the current decreases. ये हमारे पास एक normal trend आ रहा है. The current in I from the battery is changed by varying R from 5 ohms to 20 ohms. R is the resistance of this resistor. The variation with R the variation with R the variation with R of I is shown in figure 6.2. So we have 5 ohm से 20 ohm तक इन्होंने resistance पे दिखाया कि current किसने decrease करा. Explain why the potential difference between points A and C is 24 volts for all values of R. Where is okay, so A and C, A is over here, C is over here, and these are connected to the negative and positive terminals of the battery. And because we have no internal resistance in the battery, our terminal voltage, it's gonna be A and C are our terminals, okay? That's gonna be 24 volts because our battery has no internal resistance. तो हमने यहाँ पे mention करना है because our battery has no internal resistance. The value of R does not matter because R is inside the circuit, right? And if you look at the positions of A and B, A and C, they're directly connected to the negative and positive terminals. So the value of R doesn't matter because it's not gonna affect the terminal voltage. Use figure 6.2 to state and explain the variation of potential difference across the resistor Y as R is increased. As R is increased, resistor Y, okay. As R is increased, the current flowing through here, it's gonna decrease. Okay, the current flowing through this part. And as the current decreases, what is the effect of increasing this resistance? हमारे पास जो resistance बन रही है, we have 1 divided by X plus 1 divided by R, and we're gonna have 1 divided by R total over here. So the parallel resistance is going to increase as R increases, right? The total amount of resistance, the value for resistance, it's going to increase. So because this portion of the circuit is going to have a greater resistance as R increases, it's going to use up more voltage. और अगर ये वाली circuit more voltage use करिए, that's gonna leave a lower voltage for the Y resistor. So the potential difference across Y will decrease. PD Y will decrease as combined resistance of X and R increases. Okay, so the next part, for R is equal to 6, show that the potential difference between points A and B is 9.6 volts. So for the value of R, which is equal to 6 ohms, this one, this is equal to 6 ohms, we need to calculate the potential difference across A and B. And we can get the value of I from this graph, and this is like 15 small blocks, so every single small block is 0.33. That means that we'll get a value of 6 ohms. It's right about here, and we're gonna it's gonna be this point. One, two, three, four, five, 2, 3, 4. Okay, so this is 2.4 volts. Sorry, 2.4 amps. So we have a value of I is going to be 2.4 amps, and R is 6 ohms, 6.0 amps. Okay. Hmm. That okay, no, wait. The current I from the battery. So this current I is the total current. It's labeled over here as well. This is I, the total current from the battery. So that means because we don't know the value of X, this is unknown. We don't really know what resistance this is, so we can't really find out the current going that's dividing, right? We don't know how much of the current is going to R and how much of the current is going to X. But because the current rejoins over here, let me just draw it properly. The software first. Okay. So what's happening to the current is that Kirchhoff's first law, the current law, was that the total current entering the junction and leaving the junction is same. So if you look at the junction A, I is entering, and some of I is going over here, and some of I is going over here. It's dividing. And if you look at junction B, this current goes over here, this current goes over here. So over here back we have I again, like on this side of B. So the current I is also flowing through the resistor Y. So what we know is that the total current I is 2.4 amps, and we know the resistor Y, so we can find out the terminal resistance across this B and C. And to get the terminal voltage across A and B, we can just subtract the terminal voltage across B and C, because that's what Kirchhoff's second law was, that EMF is equal to the sum of voltage drops in a closed loop. So let me just draw a closed loop in the circuit. Our loop is going to be this, right? We have some voltage drop against X, and we have some voltage drop against y. So, and because x and r are in parallel, the voltage drop against x and r that's gonna be the same. That's not gonna be different. And this is our loop. Okay, this is our loop. Our EMF is 24 volts, and Kirchhoff's second law was total EMF is equal to total voltage drops in the loop. Our total EMF is 24 volts, and our total voltage drop is the voltage drop across x plus voltage drop across y. So that's gonna be voltage across x and voltage across y is equal to 24. The sum of these are voltage drops, Vx and Vi. So if we get Vy, if we can calculate a value of Vy, we can get Vx is equal to 24 minus Vy, and that is going to give us the value of Vx, which is also the terminal voltage across A and B. So if we calculate Vy, so this this 6 is for the graph, and the one we're using right now is the resistance of Y. Both of them are 6. Vy is equal to 2.4 amps multiplied by 6. That's gonna give you a value of 2.4, 14.4 amps. Okay, and our Vx was equal to EMF minus our Vy. Vx is equal to EMF is 24 minus 14.4, and that's gonna give us 24 minus 14.4, 9.6, and that's your answer. Calculate the resistance of X. Okay. Now that we know that the potential difference across X and A and B is 9.6, so this and this is 9.6. That means the resistance across the voltage across our resistor R, that is also 9.6. So using that we can calculate the current through our variable resistor. हम ये क्यों कर रहे हैं? क्योंकि clean this up again. From the previous part we know कि A और B के क्रॉस ना from this point to this point हमारे पास जो resistance potential difference है ना वो 9.6 volts आ रहा है, ठीक है? And we know that the total current entering is 2.4 amps. What we don't know is कि कितना करंट यहाँ पे जा रहा है, कितना करंट यहाँ पे जा रहा है. लेकिन इन्होंने हमें ये भी बताया था कि 2.4 amps तब है जब हमारी R की resistance 6 ohms है. So we can just write this as 6 ohms. अब we know the resistance 6 ohms. We also know the potential difference, which is 9.6 volts. We can calculate the current flowing through R, this variable resistor, or then using the Kirchhoff's first law, which was current entering the junction and current leaving the junction are equal. So 2.4 amps would be the current entering the junction, ये वाला नीचे जो आ रहा है इस junction के अंदर जा रहा है, and the current leaving the junction, which is going away from the junction, that is the current through X plus the current through R. And using 6 ohms and 9.6 ohms we can calculate the current through R, and then we can just subtract that from 2.4 and we can get the current through X, and using that current through X and 9.6 we can get a value of resistance for X. Okay, so current through R is going to be, our resistance is 6, our potential difference is 9.6, V is equal to IR, I is equal to V divided by R. That is 9.6 divided by 6. 9.6 divided by 6. It gives 1.6 amps. So the current across our resistor R is 1.6 amperes. So this is 1.6 amperes. So now we know this and this, we can calculate the current through X, and that is going to be 2.4 minus 1.6. Current through X is equal to 2.4 minus 1.6. That is 0.8 amps, 0.8 amperes. Now we have the current and we have the voltage across X as well, because these were in parallel. The voltage difference from the official equation proved here 9.6, that's also going to be the voltage drop against X. V is equal to IR again. R is equal to V divided by I, and our voltage drop is 9.6 divided by 0.8 amps. That's going to give you a value of resistance. 9.6 divided by 0.8, 12. The resistance is going to be 12 ohms. 12 ohms. Calculate the power provided by the battery. Power is equal to VI, and our voltage was, I believe, 24 volts. Our EMF was 24, and our current was 2.4. So the total power provided by the battery, that is going to be power is equal to VI. We're just gonna multiply these together, and that's gonna give us 24 multiplied by 2.4. 24. It's gonna give us a value of 57.6 watts. State and explain qualitatively how the power provided by the battery changes as resistance R is increased. Okay, so as resistance R is increased, we can see that the current from the battery, I is the current from the battery, right? As resistance R is increasing, the current from the battery is decreasing, and power is equal to V times I. This is our EMF. This is gonna remain the same. This is not changing. But our current is decreasing as resistance is decreasing. So as our resistance increases, current decreases, and as current is decreasing, the product of EMF and current also decreases. That means our power decreases. That just means that we can just say the power provided by the battery decreases as R is increased.